Okay, this is lesson 46 for 7th grade, and today we're talking about rates. And I don't have as much time today, so I'm going to go through this a little more quickly, but once again, use the pause and the rewind, however you want to do it. Plus, we'll be going over this tomorrow as well, so just keep all that in mind. Alright, so today we're going to talk about rates, and we're going to talk about what we think of when we hear the word rates. It's something that comes up quite often in real life, and we'll show you some of those things. A rate is a ratio of two measures, and you can see how the root words match here, rate and ratio. They are very related because a rate is a ratio of two measures. Alright, we're going to consider the following examples here, and can we identify the two measures in each example? Alright, rate of speed. We see this one all the time on a daily basis, 65 miles per hour. The two rates here would be distance and time. So miles per hour or distance per time. Mileage rate, 25 miles per gallon. Distance per capacity. Pay rate, that's a big one, $12 per hour. Monetary value per time. Okay? It says the word per in each rate implies division and means in each or for each. To show this relationship more clearly, we can write each rate as a fraction using 1 with the unit of the denominator. I've done this before, so you've seen it before, but now we're actually going to apply it ourselves, unless you've already been copying the things that I've been doing. But all they do is take these three things and rewrite them as fractions. 65 miles per hour. That means you're going to go 65 miles in 1 hour. You've all heard me ask this before. If we're trying to figure out how far we're going to go in 3 hours. Well, if we're at 65 miles per hour, we know in 1 hour we're going to go 65 miles per hour, or 65 miles, so we multiply this by 3 for 3 hours. Okay? 25 miles per gallon. So that's 25 miles per 1 gallon. $12 per hour. $12 per 1 hour. Division. These are mean division. That's what the per means. So these are just rewritten as fractions this way. Alright, that's going to come in handy for us. And we're going to use this one quite a bit too, and especially in the future. Notice that a rate of speed is a distance traveled divided by the elapsed time. So rate equals distance over time, or in the more generic form, R equals D over T, where rate equals distance over time. We'll get into that. That's why 65 miles per hour is in this format. Distance over a time. Alright? Alright, so let's apply all this. Arnold drove 390 miles from LA to Sacramento in 6 hours. What was his average rate of speed? Okay? Couple things here. Average, that means divide. And we're looking for a rate, so we're looking for a ratio. So speed, or rate, is distance over time, as we just saw. Okay? So in order to figure this out, we would set this up as 390 miles, that's the distance, miles, per our time. 6 hours. Time matches with here, so 6 hours. Alright, so 390 divided by 6 should give us our answer, and we're going to be in miles per hour. So 390, 6 goes in there 6 times, 36, do our subtraction, 6 goes in there 5. Alright, so 65 miles over 1 hour. That's if we were to reduce this. If we divided this by 6, we'd get 1. If we saw that when we divided this by 6, we got 65 miles. Alright, so 65 miles per hour, or you could have just done, after we divided 65 miles per hour, mph. That'd be okay too. Alright. So if we were to do this one, and I'll just kind of take us through it, we won't do this one. On the 390 mile trip, Arnold's car used 15 gallons of gas. His car averaged how many miles per gallon? This actually sets us up for us. Miles per gallon, or miles divided by gallons. So 390 miles per gallon. 390 divided by 15, or 390 divided by 15. That would get us our answer. That would be miles per gallon. Okay? These are all different rates. Okay, now let's take a look at this one. Jared was paid $480 for 30 hours of work. What was Jared's hourly rate of pay? Okay? $480. And we're going to look for dollars per hour, or 30 hours. So 480 divided by 30 should give us our answer. I'm going to take a shortcut, cross off those zeros. 48 divided by 3 is 16. So $16 per hour, about. Pretty good amount. Okay? So there's $16 per hour. Alright. Unit price is the cost for a single unit of a product. It is a ratio of price to quantity that is often posted in supermarkets to help customers identify the better buy. One of many ways to express unit price is cents per ounce. Okay? So this is something you can use to figure out what's the better buy when you're comparing different brands of something, let's say cereal, like they are in this one. There isn't a comparison, but they show us how to find the unit price. The unit price of 24-ounce box of cereal priced at $3.60. So it says the cost for a single unit of a product. So we're looking for cents per ounce. So that means cents divided by ounces, or $3.60 divided by 24. So what is 1 ounce going to cost us? We would do 3.60 divided by 24. And if we did that real quick, 24 goes into 3 0 times, it goes into 36 once. Subtract, we get 2, 1. Drop this down. 24 goes into 120. See, 5 times? 5 times 4 is 20. There we go. Alright, so 15 cents per ounce. Okay? 15 cents per ounce there. So if you're comparing two different sizes of cereals at different prices, you can figure out price per ounce, and it would help you figure out what the better buy is. Okay. Gina wants to know how much she will earn working 40 hours at $16 per hour. How much will she earn? Okay, now they're telling us that she's earning $16 per hour. That means in 1 hour, she'll earn $16. Now we're going to set up a proportion. So, how much is she going to earn in 40 hours? Okay, so we're looking for this right here. We're looking for that x. One thing we could do, cross multiply and divide. 16 times 40, and then divide that by 1. But if we divide by 1, we get the same answer. So really, 16 times 40 should get us the right answer. If we look at it this way, to get from this denominator to that denominator, we multiply by 40. So 16 times 40 should give us our answer anyway. So 16 times 40 should give us the correct answer there. I won't go ahead and do that one, but that's how we would do that. Okay. I have a lot of examples here. Let's take a look at what we got here. Yeah, we'll go through them quick. Alright, Linda's car holds 12 gallons of fuel and averages 26 miles per gallon. If she starts a 280-mile trip with a full tank of gas, is she likely to reach her destination without needing to refuel? Alright, 280-mile trip, and it's 12 gallons of fuel. It averages 26 miles per gallon. So, let's see here. If we look at, let me grab a drink here quick. Alright, so holds 12 gallons of fuel and 26 miles per gallon. Alright, so we got to figure out 12 gallons, and it gets 26 miles per gallon. We're going to multiply those because we need to figure out if we can get 280 miles with a full tank of gas. So full tank would mean there are 12 gallons of fuel and we're at 26 miles per gallon. So for each gallon we get 26 miles basically. So let's see if this comes out to get us to this destination. 2 times 6 is 12, 4 plus the 1, add our 0, 6, 2. Add these together, 11, 312 miles. Alright, so with a full tank of gas we should be getting around 312 miles, which should definitely get us past 280 mile trip. Alright, next one. Shelly needs to drive 180 miles from her home to Austin. If Shelly begins her drive at 9 a.m. and averages 60 miles per hour, when can she expect to be home? Okay? 180 miles from home at 60 miles per hour. So how long is it going to take her to go 180 miles? Well, 60 miles per hour. So in 1 hour, she'll go 60 miles. How far is she going to go, or how long is it going to take her to go 180 miles? Notice how I have things lined up, miles and miles. And now we're going to look for X, or how many hours. Okay? 6 times what gets us to 180? Or 60 times what gets us to 180? Check my time. We're getting there. 60 times 3 gets us to 180. So we would do the same thing down here. So times 3, 1 times 3 is 3. So X would be 3 hours. So it takes her 3 hours going that speed. She left at 9. 9 plus 3, 12 p.m. So we'd be looking up there. Okay? I think we've got one more, which I'll cover real quick, and then we're going to be done. Alright, important formula that relates to distance, to rate, and time is the following. Distance equals rate times time. So, if we estimate that these riders can ride 7 hours each day and average 12 miles per hour, how far does Felipe estimate they will ride each day? Well, we just fill in what we have here. 12 miles per hour, that's right here. And he estimates that they're going to ride 7 hours each day. Times 7. So 12 miles per hour for 7 hours each day. 12 times 7 would get us our answer there. Alright, I'm going to call that a day for now. We'll see you tomorrow.